morning. My name is Praveen. I'm a senior principal engineer in a company called Discover. For those who do not know Discover, they're one of the large credit card issuers in US, and they also run a global payments network, including Diners Club International. I'm here to talk about contract testing. Before we get started, just a quick poll. Can you show hands how many of you already know what contract testing is? It's quite few. How many actually do contract testing? Okay, some of you. Nice. Hopefully, all of you will find something useful in this session. I'll share my experience in implementing contract testing and scaling it across the organization. And I'll also talk about some of the strategies you can apply, different workflows from CICD perspective, and some open source tools that can help you get started. If you think about why many organizations are moving towards microservices, of course, there are several reasons, but some of the common reasons are easy to scale, easy to release, frequent releases, independent releases, having autonomous teams with full end-to-end ownership from building to all the way to running in production. But in reality, many struggle to realize some of these benefits. In Discover, we had some challenges, especially in terms of speed and frequency of releases. We captured a lot of metrics trying to find out what was going wrong. Some of the metrics we captured from CICD pipeline were quite useful, actually. That helped us identify exactly where the bottlenecks were. What you see here is the CICD pipeline view that we use within Discover. It's a high-level view. Of course, there are several other stages. What you see here is focusing only on the key stages. Starting with CI builds, we are reasonably good with that. Then running unit tests as part of CI, we are reasonably good with that as well. Running component tests. A component is an independently deployable thing. That's a definition of component for us. Testing such components in isolation is what we call as component testing. We are reasonably okay with that as well. Then we get into this end-to-end testing. This is where we need dedicated test environments, a lot of coordination between different teams to make sure all the components and the right version of the components are deployed in the environment. This is where things slow down drastically for us. Once we get past this stage, we then go into go, no-go decision-making process. This is where we have to raise change tickets, getting approvals from various stakeholders, basically making sure it's safe to deploy in production. Anyone in financial services industry probably would be familiar with this type of process. We have done a lot of automation in this space, so I would say we got this under control. Then finally, deploying in production and releasing to customers. We are getting good at this with the modern deployment strategies like blue, green, or canary releases. So a green tick for that one as well. So if you look at this overall pipeline view, end-to-end testing in the middle, that's where we have been seeing a lot of bottlenecks, and that's the area which have been slowing us down. Let's dig a bit deep into what's going on with end-to-end testing. Let's look at this with a simple example. Let's say we have 3 microservices. In real world, you're going to have many of those. Keeping it simple here, let's say they communicate with each other synchronously through maybe HTTP protocol. Then some of them communicate asynchronously through queuing technologies like RabbitMQ or Kafka. Then we have API gateway and UI sitting at the front. If you were to test this end-to-end, you would drive the request all the way from UI, flowing through the gateway to those microservices, and you get a response back. You would do this over and over again with different scenarios. When all of your tests pass, then you will have confidence that you have a working system that's going to work in production as well. That's the main benefit of this approach. You have high level of confidence from this testing. But there are several downsides. These tests are going to be very slow because they go over the network, making multiple hops. And over a period of time, the number of tests tend to increase, especially if you are highly dependent on feedback from this type of end-to-end tests. And even if you have fully automated these tests, these can easily take several hours to run them. And due to the very nature of these tests with several moving parts, they tend to be very fragile. Then the other main challenge is test environment stability. End-to-end testing requires a fully integrated environment, which becomes complex, and that's typically shared by multiple teams. You don't necessarily have control over how other teams use your environment. Things break very often and causes frustration, and you lose a lot of time in that process. It basically slows you down. Then test data management can become very complex when it comes to end-to-end testing. And it's hard to debug when something fails, what has failed, where it's failed. You might be spending a lot of time trying to figure out if it's an environment issue or a data issue or an application issue or a test issue. You get the picture. All at once deployment. Because you're testing all these components together, you're likely to feel confident only when they are deployed together, which goes against the core principle of microservices, which is doing independent deployments. Then ownership is another challenge. It's unlikely that a single team will have ownership of all these components. Which team is going to write and own these end-to-end tests? That ownership is not very obvious. And scaling is another big challenge. End-to-end test is not a very scalable approach. When you try to add more components to your system, along with new teams, the complexity in terms of managing the environment and the data, that grows exponentially. That leads to release queues building up, and you're likely to see large, big bang releases as opposed to small and increment and fast releases. These are some of the main challenges with end-to-end testing. Despite all these challenges, if time is not an issue for you, then this is still a good approach. Because you get a good level of confidence from this testing. But in today's CICD world, testing is expected to be continuous, and you need extremely fast feedback from testing. That's when we came across contract testing. Let's use the same example with those 3 microservices. Here, contract testing focuses on all those integration points as opposed to looking at the whole system together. It captures the needs of each side of the integration point and tests each side of the integration point separately by marking the other side. Contract testing provides a mechanism to ensure those marks actually reflect reality, so we have confidence on those marks. The good thing about this approach is we are looking one thing at a time. If I'm testing microservice 1, I don't really need microservice 2 or anything else in place in order to test my service. I'm just looking one thing at a time. Let's look at all the benefits that comes with contract testing. It's much simpler because you're testing integration without having to deploy. When you don't have to deploy, then you don't need dedicated test environment and the complexity that comes with it. These tests can run locally on your laptop. They can scale linearly. These are more like unit level tests, and you don't need to bring rest of the world in order to run your tests. But straightforward. Then if you can test your integration independently, then you can deploy and release them independently as well. And it removes the need for complex release coordination because we have information about all the contracts. We know exactly which components are compatible with one another and which ones have been verified. Therefore, it gives us the ability to make data-driven decisions as to whether it's safe to deploy to production at runtime. These are the main benefits of contract testing, which addresses the challenges we looked at with end-to-end testing. There are different strategies that you can apply to contract testing. Let's look at some of the common strategies. Starting with provider-driven. With this strategy, provider defines a contract and publish that contract to all of their consumers. And this contract could be in the form of open API spec or something similar. Then we have a lot of tools today in the market that can automatically create mark based on the specification on the contract. Consumers then use that mark to do the testing. Very simple, straightforward to implement. But the challenge is the mark that gets automatically created from the contract or the spec tends to be very basic. It's not very intelligent enough. For instance, if you're In your OpenAPI spec, you may see a list of all the response codes that could be returned, 200, 400, 403, and things like that. But it will not say which set of input results in exactly which response code. Therefore, the mark will always return the first one in the list, which may not be the one that the consumer actually needs as part of their testing. This can be solved by adding some sort of custom definitions to your OpenAPI spec if that's what you're using. It might make things a little bit complex, but it's a problem that can be solved. Leaving that aside, the main challenge with this strategy is provider doesn't have much insight into how consumers actually use their API. For example, let's say a provider wants to get rid of one of the fields in the response, which they think none of the consumers actually are using it. But they do not know for sure. They don't have test-based assurance. Therefore, they are likely to make an assumption. It's a breaking change and end up creating a new version of the API, V2, which comes with its own maintenance burden. Provider will have to maintain both V1 and V2 until all of the consumers move to V2, which is probably okay, especially when it comes to public APIs. It's normal to sort of maintain multiple versions, 3 versions normally. But we felt we need a bit of flexibility when it comes to internal APIs, the way we want to evolve the APIs and how we version. That takes us to the next strategy, which is consumer driven. With this strategy, consumer make use of a mark to do the testing, and they have full control over the mark. They can configure the way they want the response and the response codes within their control. The interaction between the consumer and the provider mark is captured in the form of consumer contract. You can think of this as kind of a subset of provider's API. Then this contract needs to be verified against the provider to make sure provider is compliant with all of their consumer contracts. There are 2 methods by which this verification can take place. The first method is what I call as code-based verification. With this method, the contract gets verified against provider's code base, their actual implementation. Therefore, you get good level of guarantee with this type of verification. On the flip side, the workflow can become somewhat complex because you need to start an instance of the provider and manage the provider states depending on what's defined in the consumer contract. The other type of verification is schema-based verification. With this method, contract is verified against provider's specification, their contract, as opposed to their actual implementation. This is much simpler, straightforward to implement, simple workflow. But the downside is the level of guarantee you get is going to be much less compared to code-based verification, because it's more like a static comparison between 2 schemas. You'll be able to catch some of the basic compatibility issues, but not all type of issues. We went with code-based verification because the level of guarantee is important to us, especially when we are trying to reduce the reliance on end-to-end testing. The complexities that come with that workflow, we managed to abstract them away through automation. I'll talk about that a bit later. At some point in future, we want to do both code-based and schema-based so that we get the best of both worlds. Either way, the important aspect of this strategy is capturing the consumer contract. That's the one which helps providers with their API evolution. If I use the same example as before, where a provider wants to get rid of one of the fields in the response, with this strategy, they'll immediately know whether they're going to break any of the consumers or not, simply by verifying against their contracts. They get test-based assurance and feedback. There's a systematic way of verifying that and providing that feedback. That really helps provider with their API evolution. This strategy is suitable more for internal APIs only, because it's going to be extremely challenging capturing the contracts of your external consumers. In the case of public APIs, where you have external consumers, probably provider-driven strategy is more suitable. But when it comes to internal APIs, we felt consumer-driven contract testing is more appropriate, because that gives us more flexibility in terms of how we version and avoid versioning if it's avoidable. So we've chosen this strategy. And the next step is to pick a tool for the strategy we have chosen. When we explored the tools in the market a while ago, there were two tools, both open source tools, which kind of stood out. One of them was Spring Cloud Contract. The other one was called Pact. We did few rounds of POC and experimentation with both the tools. Spring Cloud Contract actually started as a provider-driven tool, but it's possible to do consumer-driven contract testing with that tool. Just have to bear in mind those contracts need to be written by hand and kept outside of consumer code base, which creates potential for drift. That is, the consumer contracts can go out of sync with the consumer code base over a period of time. So you need a mechanism in place to spot that whenever it happens. It works well in Spring ecosystem. If you are using Spring, you may find this tool very easy to use. On the other hand, with Pact, consumer code generates a contract, therefore there is no danger of drifting. Pact is not tied to any single language. You have native support for multiple languages, especially all the modern languages. It provides a mechanism to manage provider states. This is Pact's way of addressing the usual challenges that comes with managing test data complexities. It also comes with something called Pact Broker. This is a separate product on its own, which is used to manage all the consumer contracts and the verification results in a centralized place. It also helps massively with the automation and integration with CICD pipeline. It's highly optimized for use with contracts generated by Pact framework, but it can also work with any other type of contract as long as that can be serialized to JSON. It has integration with Spring Cloud Contract as well. We went with Pact because it ticked many boxes for us. Multi-language support was one of the key factors, but both are good tools essentially trying to solve the same problem. If you're tied to Java and Spring ecosystem, then you may find Spring Cloud Contract more suitable in those cases. If you want multi-language native support, and if you have decided to make use of Pact Broker to manage your contracts in one place, then Pact may be more natural choice in that case. It's entirely up to your use cases and the factors and the needs that you have based on your use cases. So we have now selected the tool for the strategy we have chosen. At this point, it might be tempting to say to teams, hey, here's a tool for contract testing, go and start doing contract testing. But it's unlikely to get much traction. I'm saying this with confidence because we've learned from making those mistakes. Developers can go and write contract tests, but they can go only so far. If you were to get the true benefits of contract testing and leverage some of the powerful features of Pact Broker, then you need to set some standards, streamline the workflows, and achieve some level of consistency across all teams in terms of how they interact with Pact Broker. We achieved that level of consistency by integrating our contract testing workflows with CI/CD pipeline. The workflows are going to be a bit different between consumers and providers. Let's start with consumer workflow. It's the same CI/CD pipeline view we looked earlier. As a reminder, the aim here is to reduce the dependency on end-to-end testing, keep that as small as possible. So where does contract testing fit into this pipeline? We added that next to unit test. They are run as an extension to unit test as part of the pipeline. When those tests are run successfully, a contract, otherwise known as Pact, is generated, which gets published to Pact Broker. That's where we store all the packs or contracts. Now, as a consumer, I want this contract to be verified by my provider and get immediate feedback from them. Provider, at some point, whenever they run the pipeline, will verify the contract and provide that feedback through Pact Broker, but that's going to be delayed feedback. Consumer do not have control over when provider is going to trigger the pipeline. So what we did, we set up some webhooks within the Pact Broker. Whenever Pact Broker detects a new contract or a change in contract, the webhook will trigger a standalone verifier job. The only purpose of this job is to verify the contract and verify the contract against the right version of the provider, one of the versions, the production version, and publish the results pass or fail to pack broker. And the broker will then send a notification to the consumer with the results, and this is how we close the feedback loop for consumers whenever they make a change to their code base. Then the next stage we added is called Can I Deploy? It's actually one of the features of PackBroker. It's basically sending a query to PackBroker asking, hey, I'm about to deploy this version of consumer into this environment. Am I compatible with my providers already deployed in this environment? PackBroker does some compatibility check and it says yes or no. If it is yes, then the pipeline proceeds with the deployment. If it is no, then it triggers the conversation between provider and consumer to sort out the compatibility issue. Let's say the pipeline proceeds with the deployment and the deployment is successful. It is very important to record the deployed version with the PackBroker. That's how PackBroker gathers the information about what is deployed where, and it uses that information to build a whole compatibility matrix, which it uses to answer the questions and queries like can I deploy that we looked earlier. So that's the high-level view of consumer workflow. Now let's look at how the workflow looks like from provider perspective. It's the same pipeline view. Here we added a new stage called verify contract. As part of this stage, it pulls the consumer contracts from PackBroker, does the verification, and publish the results pass or fail to PackBroker. A bit straightforward. Then the next stage we added is called Can I Deploy, which is very similar to what we looked at with consumer workflow. Then finally recording the deployed version with the PackBroker, which is again very similar to consumer workflow. So if you look at this, the provider's workflow is a bit simpler compared to consumer workflow because there's no complexity with the webhooks and that standalone verifier job. A bit straightforward here. When you put both the workflows next to each other, this is how it looks like. It looks a bit complex, doesn't it? There are a lot of interactions with PackBroker, webhooks, and that verifier job. We felt there's a lot going on here, which might be overwhelming for the developers, and it could affect the developers in a developer experience in a bad way. So we abstracted away most of those complexities away from developers so that they could focus only on those two orange boxes. Consumers would focus on writing contract tests, and the providers would focus on writing the verification tests. Rest of the stuff which disappeared from the screen still happens behind the scenes, but developers don't have to worry about those. A pipeline will take care of those things in a more opinionated way. It can be controlled through simple configuration in the pipeline. So the aim here is to simplify by abstracting away the complexities, which is exactly what we did. And that helped our developers to get on board with contract testing. At that point, we started seeing some success and the adoption was beginning to pick up. The next natural step is to scale up, going from a handful of teams here and there to hundreds of teams across the organization. I'll share some of the things we tried in terms of scaling up. We have communities centered around each discipline. We call them guilds. We have a testing guild. We use that forum initially to socialize this idea about contract testing. Once the community is convinced about this idea and the benefits they get, we had a lot of volunteers who wanted to try this out in their respective areas, which helped to get that initial traction. Then we created getting started guides along with some sample projects with working examples from both consumer and provider perspective. That's very important because that's the first thing developers look for when they try to write the contract test for the very first time. Then training and workshop. We have something called Discover Technology Academy. It's an internal platform for our engineers to build their craft. We use that platform to provide training and workshops related to contract testing, which turned out to be extremely useful. Then we gathered metrics to measure success, and the initial success stories that came up were so powerful, it motivated a lot of teams around them. It had a cascading effect in a positive way and helped to build some momentum from that success. Then finally, evangelizing. We identified a few contract testing champions from different areas of the organization. They became evangelists for this practice, and they play an important role in supporting this practice across the organization. These are some of the things we tried in terms of scaling up, and we have seen some success. Having said that, Discover is a huge organization. We have some areas which are mature, and they have fully embraced this contract testing practice. But there are some areas who are a bit less mature, and they are just getting started or exploring this. And there are some areas where the technology is too old, and this doesn't even apply to them. So we have mixed level of maturity levels in the organization. But we certainly have traction, and things are moving in the right direction. The adoption rate has doubled in the last 1 year, and we are pleased with the progress we have made so far here. Then finally, a quick summary of our journey, which could be your takeaways if you're looking to start your contract testing journey in your organization. Set the strategy, provider-driven or consumer-driven or bidirectional or mix and match, depending on your use cases. Pick the tool for the strategy you've chosen, and make sure you do a POC just to make sure that it works for you. Then integrate with CICD pipeline. This is a very important step I cannot stress enough. This is a prerequisite before you can scale up. So make sure you cover that. Then there are going to be complexities in your workflow. Make sure you abstract them away through automation and somewhat opinionating your workflows so that you don't bombard. Not giving too many options to developers is a good in certain ways. So keeping the workflows opinionated always helps. Scaling up, we just saw some of the things you could try there in terms of scaling up. Then finally, gather metrics to measure success, because you want to know whether contract testing is actually adding value for you. If it is adding value for you, then that's a point you can start reducing reliance on end-to-end testing. Just to clarify, I'm not saying eliminate end-to-end testing altogether. What I'm saying is don't rely on that too much. I still believe there's value in doing some level of end-to-end testing as long as it can be kept to bare minimum and it's focusing only on the critical user journeys and you get a fast feedback from that end-to-end testing, then it adds value. With that, we've come to the end, and before we open up for Q&A, there's some acknowledgements. Thanks to Pact open source community, they've put together a lot of useful resources related to Pact. We found them useful. If you have decided to use Pact, then I would highly recommend you take a look at docs.pact.io. That's a good starting point. It's got loads of useful materials, getting started guides, workshops, working examples for different languages. There's a lot of good stuff there. And plugins, which is a recent development, which I haven't mentioned anywhere yet. Yeah, so that's a good place to start, docs.pact.io. And thank you very much for listening. Any questions?
Yeah. Hello. Yeah. So, the question is, if there are any issues with the contract between the consumer and provider, how do you go about dealing with that? Is there an automated message that gets sent out to both teams or something?
Yes. So we added a mechanism within the pipeline that will automatically send notification. If there is an issue with contract, whenever the provider verifies a contract, you would expect that to fail, and the notification will be sent to the consumer so that they can act upon it. So there's an automated way of notifying things when something goes wrong. Good question. Thank you.
Hi. Do you run the can I deploy only for prod environment or in the deploy for the dev environment?
Good question. We recommend we start with prod because if you think about this contract testing, one of the things we try to achieve is by reducing the number of lower environments and the complexity, if you like. So yeah, prod. And if you have something like staging or another environment which you don't want to break often and you want to get that feedback early, then yeah, I would recommend doing that for those sort of environments as well.
Okay, thank you.
It's probably a similar question as the one before, but how do you handle it if there are multiple contracts in use, right? One on prod, another version on, I don't know, QA, and another one on the dev staging environment. Do you test against all of them, or do you just pick the latest one or the newest one, or is there any strategy?
Yeah, good question. So it is configurable. You can configure saying I want to verify against all deployed versions. And whatever deployments you're recording with PackBroker, it will verify against those. That can all be controlled through configuration. But by the normal configuration people go for is verify against production by default and the master version. And any other environments, it's entirely up to you. Okay.
Hi. Could you dig into how you generate the consumer contract tests a little bit? So you said you linked it to the unit tests. Does that mean you have to have like some kind of proxy in front of the stub or mock or whatever you're talking to, and that's what generates the contract?
The way you write contract tests is very similar to how you would write unit tests. As part of the test, you would describe how the interaction is going to look like, and the packed framework will then run the test, and if it's successful, it will automatically generate a contract in the format in the packed format. And the mock that it has capability to create mock automatically based on how you have defined your tests. So that's one way of generating. There's other way of generating is if you want to use your own mock, then if you can capture that interaction, there are some tools which you can use to capture those interactions. And you could convert that into packed format, and that becomes a contract. So there are different ways you can do it. Welcome.
Thanks for the insightful talk. You briefly mentioned measuring your contract testing endeavors. Can you share an example of what metrics you gathered and what insights they produce?
So there'll be a temptation to sort of go mad with those metrics, right? So we try to stick with, at least so far, the DORA metrics, especially two of them. Change failure rate, that gives an indication of how good the quality, and speed of delivery, that's a mean time, lead time to change. Those are two metrics we try to measure. Combination of those two will give you an indication of how speed your pipeline is, how fast you can get change to production, and the other one gives a measure of the quality. Ultimately, that's why you want to sort of measure, right?
Thank you. Hi, I was just wondering, so say I was a provider and I wanted to make a change to an API, maybe remove a field or something. Using your pack broker, would you be able to, does it provide like an API which would say, oh, well, if you do this, then these are the consumers which you will break, so you need to talk to those people in advance?
Yes. You'll be able to do that when you're you can, as a provider, you can run those verification tests locally on your machine, and you can pull the contracts of your consumers from the pack broker, and you will know which of your consumers you're breaking as part of your change. And there are concepts like pending packs and work in progress packs. If consumer is kind of in the middle of a change and it's in their feature branch, pack broker allows you to sort of verify those contracts, pending contracts as well, and provide the feedback to the consumer. But if it is pending, it will not block you as a provider. It'll still let you sort of go through your pipeline. So yeah, that can be controlled through configuration. Those sort of things we felt most of the developers don't care about these sort of things, pending contracts. So we set some sensible defaults, which kind of automatically happens in part of the workflow. And yeah, does it answer your question?
Different kind of question. Were you end-to-end tests already very focused on service-to-service interactions, or did you have to add other kinds of tests to actually replace end-to-end tests with contract tests, like UI tests or something like that?
Sorry, I didn't quite catch it. Can you repeat that question, please?
Were your end-to-end tests before you started contract testing, were the end-to-end tests already very focused on service-to-service interactions, or did they also cover user interactions that you had to replace with other kinds of tests, like UI tests, to actually reduce the end-to-end testing?
If I understood that correctly, the scope of end-to-end testing is what you're talking about. It depends. There are some systems which don't have UI, but they have a lot of moving parts, multiple services. We try to sort of put together all of those, which make up a system, and do that system level testing, end-to-end testing. There are some systems which have UI as an interface, and we include UI as part of that end-to-end testing. But the idea is to keep that small and just focus on the critical user journeys. Our business partners would define what those critical user journeys are and just limit to those. And rest of the core testing rules engine and things like that, that would all happen at the low level. And
Okay, I see.
thank you.
Thanks for the session, Praveen. A quick question. So I understand this contract testing is applicable for MSA-driven applications or API-based applications. So any suggestion from your side for a legacy system where we can do this kind of similar testing, but not? Yeah, just suggestion.
Yeah, very good question. So Pact initially started as is very much REST API centric with JSON payload. Recently, they've created something called a plugin framework, which allows teams to sort of create their own plugins to very specific to their use cases. And one of the use cases could be the legacy system. If it's a file-based format, there is a plugin already available for CSV format. So it opened up the use cases, and that could be used for legacy system. But if you think about legacy system, if it's a monolith, probably I don't know if you would get much value from this. You get much value if you have a lot of sort of smaller components, microservices type stuff, that's where you you need clearly defined contract between all those moving parts. Okay. Any other question? No? Good. Okay. We have a booth, Discover booth. Don't say if you have any other questions later. I'll be around. Please feel free to reach out. Or you can reach out to me in LinkedIn. Here's a link to that. Thank you very much.